dear Namaga students, this is Mrs. Sri Vidya from Pund Vidyashram. Let's have the quick recap of yesterday's session. We saw the three modes of heat transfer: conduction, convection and radiation. Conduction, it takes place in solids. Convection, it takes place in liquids and gases. And also we saw the various activities that supports conduction and convection. So today we are going to see the third mode of heat transfer about radiation. So before we go into that, let's have the quick recap of the conduction and convection. What do you mean by conduction? So conduction is a mode of heat transfer in which heat passes through a body from its hotter to the colder part or from a hotter body to a colder one is called as conduction. When you want to know about convection, the movement of particles due to the temperature difference between different parts of the same substance is called convection. Radiation, the process in which heat energy travels from one system to another in the form of electromagnetic waves with no need of material medium, that's important here, is called as radiation. In radiation, heat travels from one system to another in the form of electromagnetic radiations, that is photons. Thus, no medium is required for this mode of transfer of heat. But other two modes of heat transfer, we need a material medium to transfer heat. So what all we discussed about the previous session, let's see today. The examples of radiation is the sun's rays. Heat energy can travel in the form of waves just as light. These waves are called electromagnetic waves. That is, both heat and light and many other types of waves are called electromagnetic waves. Energy traveling in this form is called radiation. Just like light can travel in different mediums such as air and water, and in vacuum, heat radiation can also travel in different media and in vacuum. All bodies give out energy that travels in the form of radiation through space. Energy from the sun reaches us through radiation. Bodies that absorb this radiation becomes hot. The amount of heat energy that is absorbed by a body depends on its color. Bodies that are black absorb more of the radiated heat than white bodies. You would have read in your lower classes, we feel more comfortable wearing white and light colored clothes in summer. This is because white clothes absorb a lesser amount of heat than dark clothes and therefore keep us cooler. Here you have a fact file. All objects radiate heat, energy, and this property is used in infrared photography. This helps us see objects in complete darkness. Some animals can see in the infrared. For example, rattlesnakes, which is found in the xerophytes, that is in deserts, have special detectors with which they can see in absolute darkness by detecting the heat radiated by warm-blooded animals. There are few examples of heat transfer that is by radiation. A good example would be heating a tin can of water using a Bunsen burner. Initially the flame produces radiation which heats the tin can. The tin can then transfer heat to the water through conduction. The hot water then raises to the top in the convection process. The atmosphere would be another example. The atmosphere is heated by radiation from the sun. The atmosphere exhibits convection as hot air near the equator raises producing winds. And finally, there is conduction between air molecules and small amounts of air-land conduction. Now let's see about some practical applications of radiation. Heat radiations travel in vacuum and in air just like light rays. That is why electric room heaters have mirrors behind the heating coil. This reflects the heat radiated by the heating coil to the front of the heater. This way, the heat radiated in the direction behind the heater is not wasted but redirected to the front. Then, when you want to talk about solar panels, which is used in households for heating water or designed to maximize absorption of heat from the sun. A black metal sheet is used to increase heat absorption. So, these are the practical applications of radiation. Now, when we want to talk about radiation, the heat transferred by radiation is called radiant heat or thermal radiation. Now, let's see a few applications of this radiation. Why is the bottom of cooking utensils painted black, whereas the sides are sparkling bright? Black bodies are good heat absorbers and bright white bodies are poor heat radiators. The bottom of cooking utensils is painted black so that it can absorb more heat, and the sides are kept bright so that they do not radiate heat. And the next application is, why are the pipes of solar heater and containers of the solar cooker painted black? Black bodies are good absorbers of heat. The pipes and containers are painted black so that they can absorb maximum heat from the solar radiation. And next, why is it comfortable to wear light or light colored clothes in summer and dark colored clothes in the winter? We wear white or light colored clothes during summer but dark colored clothes during winter because light colored clothes absorb lesser heat and keep us cool during summer. On the other hand, black or dark colored clothes absorb more heat and keep us warm during winter. The next, why does an electric room heater has a polished surface? An electric room heater is provided with a curved polished metal reflector behind the heating element. This polished surface reflects back all the heat radiation falling on it towards the person sitting in front of the room heater. These are the practical applications of radiation that we are using it in our day-to-day life. Now, let's see about this Thermos Flask. We call it as Dewar Flask because this was discovered by Sir James Dewar. Here in this flask, the three modes of heat transfer is possible: conduction, convection and radiation. This is nothing but we have flasks at home. In order to boil the water and in order to prevent the heat loss, we used to pour water in the flask. In order to withstand more heat for a prolonged time, we use a Thermos flask. A vacuum flask, or also known as Dewar flask, Dewar bottle or thermos, is an insulating storage vessel that keeps its contents hotter or cooler than surroundings. Why it is named as Dewar flask? It was invented by Sir James Dewar. Here is a diagrammatic representation of Thermos flask. How does a Thermos flask work? Vacuum flask consists of two flasks placed one within the other and joined at the neck. The gap between the two flasks is partially evacuated of air, creating a near vacuum which prevents the heat transfer by conduction and convection. Heat transfer by thermal radiation may be minimized by silvering flask surfaces facing the gap. Most heat transfer occurs through the flask's neck and opening, where there is no vacuum. Vacuum flasks are commonly made of metal, glass, foam or plastic and have their opening stopper with cork or plastic. So, the three modes of heat transfer is possible in Thermos flask. This is a very good example of how heat loss by all three modes of heat transfer is possible. This is the diagrammatic representation of this thermos flask. You can see the silvery glass wall, that is heat loss by radiation. You have a vacuum flask, vacuum between the double glass walls, heat loss by conduction and convection, and the outer case. We would have seen at home how this work. So let's see about some activities that supports radiation. To show that black bodies are better heat radiators than the white bodies, take two cans, thermometer, black and white paints. Take two identical tin cans, one painted black and another white. Pour equal amount of hot water into these cans. Insert a thermometer in each of the cans. Place both the cans in shade for about half an hour and then read the temperature of both the cans. The temperature of water in the black can is lower than the white can. Why? This shows that black bodies give out, radiate heat faster than the white bodies. So, from this, we conclude black bodies are better heat radiators than the white bodies. And the next activity is to show that quantity of heat absorbed by your body depends on the distance from the source of heat. Two thermometers and you have a mounted electric bulb. Then place two identical thermometers at an equal distance on either side of an electric bulb. Switch on the bulb and observe the mercury level in the two thermometers. After some time, note down the temperature shown by the two thermometer. The thermometer nearer to the bulb shows higher temperature than the other. From this, it shows the quantity of heat absorbed by a body depends upon its distance from the source of heat. So, once again, I'll say this radiation requires no material medium, but conduction and convection requires a material medium. Next, let's see the next activity is to show that the black bodies are better heat absorbers than the white bodies. Take two tin cans, black and white painted, and then thermometers. So, take two identical tin cans, point one of them white and the other black. Pour equal volume of water in the two cans. Insert a laboratory thermometer in each can. Place both the cans in the sun for about an hour. Read the temperature of water in both the cans. Water in the black can is found to be warmer than that in the white can. This shows that the black bodies are better heat absorbers than the white bodies. That is what we saw in the applications of radiation. Now let's see some examples. We feel warm when we sit in the sun, in front of fire or in front of an electric heater. How does heat travel from the sun, from the fire and from the electric heater to us? There is no direct contact between us and the source of heat. The air between us and the source of heat is a bad conductor of heat. Therefore, heat transfer cannot be due to conduction. It cannot be by convection because hot air raises upwards and not towards us. In fact, heat from any distant source reaches us by another mode of heat transfer called radiation. All hot substances or objects, whether solids, liquids or gases, transfer heat by radiation. Radiation needs no medium. That's very important. Transfer of heat by radiation can occur even in vacuum. Thermal radiation is called infrared radiation. This radiation travels with the speed of light. Thermal radiation can even travel through the vacuum. Here you have some keywords for your recapping of this session. Degree of heatness or coldness of a body is called temperature. Heat energy, the form of energy that flows from a hot body to a cold body, is called heat energy. Conduction takes place in solids in which heat is transferred within a body when two bodies are in close contact with each other. Conductors, which conduct heat. Substances which conduct heat are called conductors. For example, metals. Insulators, substances which do not conduct heat. They are called as insulators. Then, do you know section? Direct. You have radiators in car, buses and refrigerators are painted black. Do you know why? Black bodies are better radiators. A bright shiny surface is a poor absorber of heat radiation because it reflects the radiation falling on it. The firefighting suit is bright and shiny so that it does not absorb more heat. So now let's see about the Thermos Flask. Here the three modes of heat transfer is possible. Conduction, convection and radiation is minimized. Heat loss due to conduction is minimized by using insulating materials such as plastic for the outer casing and the cap of the Thermos Flask. The inner jar is a double-walled bottle made of glass or stainless steel. The space between the two walls is a vacuum so that the heat loss due to conduction is minimized. This also reduces heat loss due to convection as there are no air molecules to carry the heat away. Heat loss due to radiation is minimized by making the surface of the jar highly reflective so that heat radiations are reflected back into the jar. It's very important, this Thermos Flask, because all the modes of heat transfer is possible here. The next, do you know corner? Direct transfer of heat from a hot body to a cold body having no contact between them and without the help of any medium is called radiation. The heat transferred by radiation is called radiant heat or thermal radiation. The absorption of radiant heat by a body causes an increase in its temperature. So, about the conduction, convection and radiation we had discussed. And about this three modes of heat transfer is possible in Thermos Flask. That also we discussed. So the keywords which I had given there, you are supposed to make a note of it. Here you have some true or false. Circle the odd one. Answer the following questions orally. Name the main mode of heat transfer in solids, that is conduction. What mode of heat transfer is responsible for land and sea breeze? Convection. What is the mode of heat transfer through which sun's heat energy reaches us, that is radiation? Then odd one, conduction, temperature. All these we are supposed to do it. Here you have the summary of this chapter. Thermometer is a device used to measure temperature. Thermo means heat. Meter is measuring device. Generally, mercury is used in thermometers. Liquids such as alcohol are also used. This alcoholic thermometers is used in the very cold climate. This I forgot to tell you in the before session. Alcoholic thermometer are mainly used in the places where there is an extreme cold. It has a freezing point of minus 117 degrees Celsius. Nowadays we are using digital thermometers. It's quite accurate and much easier to read, and there is no problem of the mercury getting into it. So heat is a form of energy. It flows from a body at a higher temperature to a body at a lower temperature. So these are the summary points. Hope you would have understood all the sessions in this chapter. I would like to thank all the students who patiently viewed all these videos. Once again, we can meet in the next session with a recap of the chapter. Thank you, children. Stay home, stay safe.